Hey everybody! It has been a long time since we saw each other, hasn't it? Well, I'm happy to see you back again, and I hope you're ready to learn some astronomy. Now, let's talk about Uranus again. So, Uranus was a quite interesting planet, and as I said in the previous episode, we know very little about it. Now, if we don't know much about Uranus, we know even less about Neptune. Neptune is so far away and so mysterious, we hadn't even known it existed until the 1800s. Can you believe that? Well, we're going to first understand how we discovered such a mysterious planet and learn even the sciencey bits about this planet. So, ready or not, here I come to explain you about Neptune. So, before we get into the science about Neptune, let's first understand how did we even come to learn about Neptune. You see, Neptune, as I said earlier, was not even known to exist until the 1800s. Neptune is so far away that it's not even visible in the night sky. So, how did we even know it existed? Turns out, gravity helped a lot. See, remember, in one of the previous episodes, we learned that Newton made the laws of gravity understood in a mathematical manner. That means that he wrote a set of laws that helps us to understand how gravity works. And by using those laws that Newton wrote about gravity, we were able to find out Neptune where it is. So remember earlier, William Herschel had discovered Uranus using a telescope. But at the time, we didn't have enough power or enough resolution in telescopes in order to see Neptune. So we needed to find Neptune mathematically because we didn't have the means to find Neptune in terms of observation. But we had the means by terms of mathematics. So yes, you have to pay attention in your mathematics class. Anyway, as I was saying, so this guy here called Urbain Le Vergier, a French astronomer, said, you know what, let me observe Uranus again. So he did. He observed Uranus, and applying the laws that Newton had discovered earlier, saw, no, this isn't right. If Neptune weren't there, then Uranus would move according to the predictions of astronomers using the laws of gravity. In other words, if there wasn't another planet after Uranus, Uranus would have an undisturbed orbit. But Urbain Le Verrier observed Uranus again and again, and what he found was that Uranus had a disturbed orbit. This means that the orbit of Uranus was against the law of gravity that Newton had discovered. So, was Newton wrong? Were the laws of gravity changed and Newton was obviously not doing his job right? But no. The laws of Newton were still right. And this was the deduction that helped us to find Neptune. This means that if Neptune is there, it means that Uranus is going to move as we see it. Okay, let me use a clearer example. If Uranus is moving in a certain way, then if we add Neptune, that way that it should behave is going to be disturbed. It's like saying, if I'm alone, I'm going to behave in a particular way, but add a second person, and my behavior is going to be completely different. Same thing with Uranus. So, as I told you before, Urbain Le Verrier did the mathematics using the laws of gravity that Newton had discovered, and surely enough, he discovered that there was another planet beyond it. But that was just a theory back then, but it was a great one. For the first time, a planet had been predicted using mathematical ways. But how did we even observe Neptune if it is so far away? Well, in Germany, they had enough resolution in their telescopes to observe such a faraway planet. And that's what they did. A few days later, after Urbain's prediction, Johann Galle, a German astronomer at the Berlin Observatory, discovered Neptune, just a few degrees away from where Urbain had predicted it. Isn't science interesting? Richard Feynman once said that the best part of science is not what we find, but how we find it. So yes, that part is really important. Now that we're done with the historical tidbit of Neptune, let's understand its science. For one, Neptune is the farthest planet from the Sun in the solar system. It's so far away that its orbital year is, get this, 165 years. So it means for 165 revolutions of the Earth, there is one for Neptune. This is fascinating. So I hope you have discovered this. The farther a planet is from the Sun, the longer its orbital year. So yes, this is a quite interesting science tidbit. The other thing now that is shocking is that despite its distance from the Sun, Neptune is not the coldest planet by far. The coldest planet in the solar system, as I told you earlier, is Uranus. The reason why is still a bit cloudy, but further research will tell us the specific reasons. Now, Neptune is, like Uranus, an ice giant. This means that it is mostly composed of ammonia, methane, and water. But it doesn't mean that that water is predominant. Yes, there is a lot of water compared to Earth, but that water is in gaseous form, so it's not that useful. Now, Neptune has this cool thing about it. Neptune has the strongest winds of the entire solar system. Imagine, the strongest winds on Earth that we have recorded are 300 miles per hour, somewhere around there. But on Neptune, the winds there are faster than the speed of sound. It means that if you were to speak in Neptune, the wind would travel faster than your sound. Isn't that incredible? Now, Neptune, like its brother Uranus, has moons. Not as much as Jupiter and Saturn, but it has a few dozen. The biggest among them is Triton. Triton now is very interesting, like most moons, because it has nitrogen geysers. What do you mean? On Earth, we have geysers that spew out hot steam from the Earth. But on Triton, we have nitrogen geysers that spew out huge amounts of nitrogen. Triton is really interesting, very interesting. Its surface is wonderful, and you can look at it at first and say, oh, this moon is boring. But in reality, when you look at a moon, you have to look a little closer. And then you find out how wonderful it is. Now, as much as I've told you so far, you might think, well, that's a lot of information. But that information is still few. So, when you grow up, who knows, you could be an astronomer and find out that, well, the reason for this is that. See, we have very few spacecrafts that have gone to Neptune. Very few. Around 2 only. 2. Mars has had hundreds, but Neptune has had as few as 2. So, I hope you, the next generation watching, can decide, well, let's build a space probe that will visit Neptune so that we can learn more about it. Neptune is a fascinating planet, and everything I've told you so far, as much as it seems, it's really, really little. So, I invite you to do some research. And let me ask you this. Why is Neptune less cold than Uranus? I'll leave you that question. So, see you, and hopefully you've learned about Neptune. See you next time.